Good morning, students. I'm Dr. P. Saronan, Associate Professor in the Department of Chemistry at St. Joseph College of Engineering, Oyama, Chennai. I will be handling the applied chemistry and environmental science and sustainability courses for your classes. I look forward to interacting with all of you and making the classes informative and interesting. Today, we are going to start Unit 3, Water Purification Techniques. Let me begin with a simple question. Can we survive for even a few days without clean water? The answer is no. Water is essential for drinking, cooking, agriculture, industries, and almost every activity in our daily life. However, not all water is safe to use. Natural water may contain dissolved salt, harness causing substances, microorganisms, and other impurities. Therefore, water purification is very important. In this unit, we will learn what is hardness of water and how it is expressed, how hardness is estimated using EDTA method, common boiler troubles such as scale and sludge formation, internal and external method used for boiler water treatment, desalination by reverse osmosis, municipal water treatment, and disinfection methods such as UV treatment, ozonation, and chlorination. These topics are not only important for your examination, but are also widely used in industries, power plant, and public water supply system. Clean water is one of the most valuable resources on earth, and understanding how to purify and manage it is an important skill for every engineer and scientist. Now let's begin with first topic, hardness of water. Before going to start the class, first we have to know some basic concepts like requirement. What are the basic requirements of drinking water, or potable water, or municipal water? And the water must free from color, odor, bacteria, and dissolved gases like O2, CO2, and other gaseous molecules. The water should have pleasant taste. The dissolved oxygen should be below 10 ppm. The chlorine content should be below 250 ppm. If it is above 2 ppm, it may causes scale and sludge formation. And fluoride content should be below 1.5 ppm, above which the people may get affected by fluorosis. The harness salt should contain should be below 500 ppm, and the pH range of water should between 6.5 to 8. Concept of hardness, let me say first soft water. The water which produces lather or foam easily with the soap solution is called it as soft water. This is mainly due to the absence of calcium and magnesium salt. From the slide, we easily understand the concept of soft water. When we use soap solution, it may produce a lot of foam with the soap water. Number two, hard water. The hard water, which does not produce lather or foam easily with the soap solution, but it produces a white colored precipitate, is called it as hard water. This is mainly due to the presence of calcium and magnesium salt, like calcium sulfate, magnesium sulfate, calcium carbonate, magnesium carbonate. The property is known as hardness. For example, so sodium is the high molecular weight of fatty acid, which may derive from the sodium plus vegetable oil or animal oil. So sodium stearate soap is treated with the hardness causing salt, then be converted into heavy precipitate of calcium stearate. Yes, from the slide we can easily understand what is the difference between hard and soft water. When we use soft water, it will not produce any white color scum precipitate. When we use hard water sample with the soap solution, it may produce a white scum like a precipitate. This kind of water sample is called as hard water sample. Yes, from the slide, we can easily understand what are the differences between salt water and hot water sample. Yes, the sample one is treated with soap solution. When we use soap solution, it will produce enormous volume of foam. It may call it as soft water. This is mainly caused by the absence of calcium and magnesium salt. Next, move on to the hot water sample. When we treat with the soap solution, it will not produce foam, but instead of that, it will produce white color scum precipitate. This is mainly due to the presence of dissolved minerals like calcium and magnesium salt. These are the major differences between salt water and hot water sample. Differences between hard and soft water, we see one by one. Hard water sample which contains calcium and magnesium salt, like calcium sulfate, magnesium sulfate. And soft water does not contain any calcium, magnesium salt. Um, let's move on to the second point. Does not produce lather with the soap solution. Here it will produce lather or foam easily with the soap solution. And this is due to the presence of calcium, magnesium salt. This is due to absence of calcium and magnesium salt. Soap is wasted and cleaning quality is decreased. Here, the cleaning quality is not decreased. This is due to absence of calcium and magnesium salt. The boiling point elevated more time and fuel for cooking. Here, less fuel and time required for cooking purpose. This is mainly caused by calcium and magnesium salt. Types of harness based on the uh, dissolved minerals, there are two types. Number one, temporary harness. Number two, permanent harness. Temporary harness is otherwise known as carbonate harness or alkaline harness. And the harness is due to the presence of carbonate and bicarbonates of calcium and magnesium as called it as temporary harness, which means the calcium carbonate and magnesium carbonate can easily removed by water by simple boiling technique or by adding lime like a calcium hydroxide to the water sample. Let me see the equation. In the hot water sample, I mean the temporary harness producing salt like a calcium bicarbonate can be removed by simple heating process, where and the calcium bicarbonate may decomposes into calcium carbonate plus water molecule and carbon dioxide. This kind of harness is called it as temporary harness. One more method of removal of harness by adding lime. The temporary harness producing salt can be removed by adding lime. It may be converted into insoluble magnesium hydroxide, insoluble calcium carbonate, and water molecule. The insoluble magnesium carbonate and calcium bicarbonate can be removed by blowdown operation or any other suitable method like filtration and other process. Next, we move on to the permanent harness or non-carbonate harness. The harness is mainly due to the presence of chloride and sulfates of calcium and magnesium salt, which cannot be easily removed from the simple boiling technique, but it can be removed by other process like lime soda process, zeolite process, ion exchange process, reverse osmosis. This harness is called as permanent harness or non-carbonate harness or non-alkaline harness. Yes, and the calcium sulfate cannot be removed by simple boiling technique, but it can be removed by adding calcium carbonate. Yes, and the calcium sulfate may be converted into insoluble calcium carbonate, which can be removed by filtration process or blowdown process, and may be converted into sodium sulfate. Sodium does not contribute any hardness to the water sample. Total harness. And the sum of temporary harness and permanent harness is known as total harness. How will you detect the harness? The harness can be detected by two ways. By treated with the aerogram black tea indicator. Number two, by treating with the soap solution. When we use aerogram black tea, it will give us wine red color in hot water sample. When we use soap water solution, it will give us white precipitate in place of uh, foam or leather. From the two tests, we can identify Which one is hard water sample? What are the units of hardness of water? There are four units are practiced. Number one, parts per million, milligram per liter, degree Clark, and French degree, where 1 ppm equal to 1 part by weight of calcium carbonate equivalent hardness in 10 power 6 parts of water. 1 mg per liter equal to 1 mg of calcium carbonate equivalent hardness in 1 liter of water, and so on. Boiler feed water. The water is feed into the boiler in order to get the steam is known as boiler feed water. It is a setup. It is a setup or arrangement, and the setup are used to produce steam in industries is known as boiler. The water is feed into the boiler itself and heated to produce steam. The water feed into the boiler is known as boiler feed water. It is the working setup of steam utilization of boiler. Yes, here the water sample are boiler by using coal sample. Then the steam is used to operate the turbine. Turbine is generator. Turbine is connected with the generator. Generator produce electricity. Boiler troubles are boiler problems. What are the demerits of hard water sample when we are using in the when we are used in the boiler industries? Boiler trouble meet in boiler, which are collectively known as boiler trouble or boiler problems, which may be sludge and scale, priming and foaming, caustic embezzlement, and boiler corrosion. Where the scale and sludge formation is mainly due to the presence of calcium and magnesium salt, and the priming and foaming is mainly due to the presence of some, and the priming is mainly due to the presence of maintaining the water level very high, very poor boiler design. And foaming is mainly due to the presence of some oily substances or soapy substances or grease are present in the water sample. This may be the reason for foaming. But three, caustic embezzlement. It is a kind of boiler cracking. This is mainly due to the presence of sodium carbonate. Then boiler corrosion. The boiler corrosion is mainly due to the presence of some dissolved gases like O2 and CO2. Let me see one by one. Yes, requirement of boiler water, uh, scale and sludge formation. Requirement of boiler water free from hardness causing salt like calcium and magnesium salt. If not, it will produce scale and sludge formation. Um, how can I say that? Yes, if the water sample is free from hardness causing salt like calcium and magnesium, it will not produce any scale and sludges. If we may contaminate it with the calcium and magnesium salt, which leads to make scale and sludge formation. Foaming. Foaming is a kind of stable bubbles on the boiler water sample, which do not break easily. They are very stable in nature. This is mainly due to the presence of oil, grease, and silica substances, suspended impurities of silica. Then caustic embezzlement. Caustic embezzlement is caused by the dissolved salt, suspended impurities, and alkali substances of sodium carbonate. And boiler corrosion is mainly caused by the dissolved gases like O2, CO2, and suspended salt. Let me see first scale and sludge formation. If the water contains hardness causing salt like magnesium sulfate, magnesium chloride, calcium carbonate, magnesium carbonate, calcium sulfate, calcium bicarbonate, on evaporation, the salts are precipitated. If the precipitate is in the form of slim, non-underground precipitate inside of the boiler is known as sludge. If they form very hard, thick, strong adherent coating between the boiler wall and the scale is known as uh, material is known as scale. So finally, we will conclude like this. Sludge substances are very slim and loosey substances. They may deposited or loosely suspended in the water molecule. But The scale are very strong. They are very strongly attached on the boiler wall, which cannot easily remove from the boiler. And these are the differences between scale and sludge formation. Yes, here the suspended impurities are, it may be sludges, and the thin slim, the thin deposition is, may call it as sludges. Here, the thick scale, thick material, the thick material may call it as scale. And all molecules are strongly attached on the boiler wall, which cannot be easily removed from the boiler. But the scale, sludge material can be easily removed from the boiler by blow down operation or some other technique. Here, the scale cannot be removed by blow down operation, but it can be removed by hammering method, wire brush operation method, by treating EDTA solution, or by using dilute sulfuric acid and other method. And these are the some photographic images of scale deposition. Yes, these are the scale substances. The scale is hard like a rock, which cannot be removed even by hammering method. But sludges are very soft, loosely bonded precipitate formed in the boiler, which can be easily removed from the boiler by blowdown operation. Yes, these are the some sludges. The sludges can be loosely deposited in the boiler wall, which can be easily removed from the boiler by blowdown operation or by using wire brush operation method, which can be easily removed from the boiler. Yes, scale cannot be easily removed from the boiler, which may block the water flow. These are the some common examples of scale formation inside of the pipeline. Scale deposition of the water heater. Yes, different scale level formation inside of the water heater. And next, when we will move on to the reason for sludge and scale formation. Sludge is mainly due to the presence of magnesium chloride, magnesium sulfate, calcium chloride, and scale formation is mainly due to the presence of calcium carbonate, magnesium carbonate, and calcium bicarbonate. Due to the presence of magnesium chloride, decomposes to form hydroxide and hydrochloric acid, and the former will produce soft sludges and later lower the pH value of the water sample. Yes, and due to the presence of magnesium chloride at very high temperature and pressure, the magnesium chloride salt may undergo hydrolysis, and it will give us acidic HCl and magnesium hydroxide, which can be these are the soluble salts which can be easily removed from the water by blow down operation method, and also they may lower the pH value of the water sample. And presence of calcium bicarbonate decomposes at low temperature when CO2 liberated. Calcium carbonate decomposes on the heating of surfaces. Yes, due to the presence of calcium bicarbonate and very high temperature, they may decompose into calcium carbonate insoluble salt. They may deposited as scale and CO2 liberation and H2O molecules. What are the disadvantages of scale and sludge formation? Is wastage of fuels, then lowering of boiler safety, boiler corrosion, decreases in efficiency, danger of explosion, blocking of pipeline. These are the some drawback when we are using hot water sample in your boiler industries. How we can remove the scale and sludge substances? If they are loosely deposited on the boiler wall, that can be removed by scrap method. If it is brittle in nature, we may give thermal shock. And if they are very hard in nature, we can use chemicals like what 5 to 10% HCl, or by adding complex agent like EDTA. Where the EDTA is a well-known complexing agent, they may readily complex with the calcium and magnesium salt that may convert it into soluble substances. Finally, the soluble substances can be removed by blow-down operation. What do you mean by blow-down operation? Removal of concentrated water frequently by adding fresh water is known as blow-down operation. Let me see what are the drawback when we use hot water in the boiler industry. Yes, if you use hot water sample in boiler industry, it will utilize scale and sludge formation. First one is wastage of fuel. Yes, scale have low thermal conductivity, like a poor insulating material, so that heat transfer from boiler to inside of water may not be sufficient. In order to provide steady supply of water, heat to water, overheating is to be done, which causes wastage of fuel. For example, thickness. If the thickness of the scale is 0.3 to 5 percentage, 3 to millimeter, the wastage of fuel is around 10 percentage. If the thickness increases, wastage of the fuel also increases. From the table, we can conclude, we can realize what happening when we are using hot water sample in the boiler. Next drawback is a decrease in the efficiency. Scale sometimes deposits in the walls and condenser of the boilers and heat exchanger and cause blocking. This results in decrease in the efficiency of boiler and heat exchanger. Yes, here the scale formation is strongly attached on the boiler wall of boiler wall or the pipeline. They may block the water sample, which will not allow the water sample efficiently. Boiler explosion. Sometimes due to overheating, the thick scale may crack, which causes the sudden contact of high heated boiler material with the water sample. This causes formation of large amount of steam and it develop high pressure, which leads to boiler explosion. How we can prevent the scale formation? At the earlier stage, we can use wire scrub method, wire brush method, mechanical scrubber can be used to remove scale. Thermal shock are used to remove brittle scale. When the scale is brittle in nature, we can use thermal shock. By external treatment method. External treatment is the process of removal of calcium and magnesium salt before entry into the boiler is called as external treatment, which include ion exchange demyelination process and zeolite softening method. Number four, by using boiler compounds. Boiler compounds are, it may be organic or inorganic substances. They are used to remove hardness producing salt after feed into the boiler itself is known as internal treatment or internal conditioning. Example, sodium carbonate, sodium phosphate, calgon, and EDTA method. The last one is by using acid treatment. We can add dilute HCl or dilute sulfuric acid through which we can remove the scale formation. So one of the important question, what are the differences between the scale and sludge formation? Sludges are very loose, slim, and non-adherent precipitate on the inner wall of the boiler. Scale are very hard, thick, adherent precipitate inside of the boiler wall. The scale is due to the presence of magnesium sulfate, magnesium chloride. The scale may be due to the presence of calcium sulfate and calcium bicarbonate. Due to poor conductance, they may decrease the boiler efficiency to lesser extent and causing shocking in the pipeline. Due to poor conductance, they decrease the boiler efficiency to maximum extent, cause reduced fuel economy, improper boiling, boiler explosion, etc. It can be prevented by periodical replacement of concentrated water by adding fresh water. This process is known as blowdown method. Blowdown is the process of removal of concentrated water frequently by adding fresh water is known as blowdown operation. A scale can be removed by some special techniques. The scale cannot be removed by blowdown operation. but it can be removed by some special method like the external treatment of ion exchange, then zeolite process, and internal conditioning like by using calcium carbonate, sodium carbonate, sodium phosphate, calagen conditioning, etc. Then mechanical hard scrabbling method, then by using thermal shock method. Next one is priming and foaming. Priming is the formation of bed steam is known as priming, and foaming is the process of stable bubble on the water surface is known as foaming. So I repeat once again, formation of wet steam is known as priming. Formation of stable bubbles on the water surfaces is known as foaming. And this is mainly caused by very poor boiler design, maintaining the water level very high, sudden boiling of water, uneven heat velocity may be the reason. Here, foaming is mainly caused by due to the presence of some oily substances, soapy substances, and suspended impurities like silica. Third one is caustic embeddlement. Caustic embeddlement is the process of intercrystalline cracking of boiler material. This is mainly caused by due to the presence of sodium carbonate. Yes, at very high temperature and pressure, the sodium carbonate in the water sample may hydrolysis and they may convert it into sodium hydroxide plus carbon dioxide. Due to the presence of sodium hydroxide, this makes water caustic. The caustic water may attack the boiler wall. They may convert it into sodium ferrate. I repeat, caustic embeddlement is a kind of breaking or cracking of boiler material. This is mainly caused by the sodium carbonate. At very high temperature and pressure, the sodium carbonate undergoes hydrolysis and they may convert it into sodium hydroxide, which makes water caustic. The caustic water may attack the boiler wall and they may convert it into sodium ferrate. This process is called as caustic embeddlement. The last one is boiler corrosion. Boiler corrosion is the slow and continuous process. This is mainly degradation of boiler material. This is mainly caused by the dissolved minerals plus dissolved gases like carbon dioxide and oxygen molecules. Yes. Due to the presence of dissolved oxygen, due to the presence of carbon dioxide, due to the presence of magnesium chloride. These are the reason for the formation of boiler corrosion. One example, due to the presence of oxygen, which leads to make ferric hydroxide. It is the boiler material. Water molecule contains excess of oxygen content. If the water molecule contains excess amount of volume of oxygen, which leads to make ferric hydroxide, which is called as boiler corrosions. Due to the presence of magnesium chloride. Yes, if the water sample contains magnesium chloride, which leads to make boiler corrosion. The magnesium chloride undergoes hydrolysis in presence of very high temperature and pressure, and they may convert it into HCl and magnesium hydroxide. The boiler material react with the product of HCl, then may convert it into FeCl2 SH2 gas, and the FeCl2 undergoes hydrolysis and may convert it into corrosion product. How we can remove the boiler corrosion? The boiler corrosion removed by two way. Number one, by adding chemical method. Number two, by mechanical deaeration method. How you can remove the dissolved gases by using some chemical method. When we use sodium sulfite, the sodium sulfate may absorb all the oxygen molecules, then may convert it into sodium sulfate. By adding hydrogen salt, the hydrogen salt absorb all the O2 molecule, then may convert it into nitrogen gas plus water molecule. Then by adding ammonium hydroxide, and the ammonium hydroxide are used to absorb all the CO2 molecules, and they may convert it into ammonium carbonate and H2O molecules. Then removal of dissolved gases like O2 and CO2 by mechanical deaeration method. The water is feed into this way. It is first actually it is made up of stainless steel, and the steel and the tower is made up of stainless steel. The sides of the tower is heated by heating jacket. One vacuum pump also attached together. If we in the these are the perforated plates. They are used to allow the water molecules from top to bottom. Um, First, the hard water sample is feed into, I mean, water containing O2 and CO2 water sample is sent by this way. And the sides of the tower is heated by using heating jacket. And at the same time, we have to reduce the pressure. By increasing the temperature or reducing the pressure, we can remove all the O2 and CO2 molecules. So finally, we can get deaerated water sample. So we can remove the boiler corrosion by adding chemical or by using mechanical deaeration method. How we can remove the hot water sample by using internal conditioning or internal treatment. Before going to start the classes, before we have to know about what is internal treatment. Internal conditioning or internal treatment is the process in which we can remove the hardness producing salt like calcium and magnesium, which were not removed by external conditioning or external method. For example, in the external treatment, we can remove calcium and magnesium completely before entry into the boiler. We can remove all the hardness causing salt before entry into the boiler is known as external treatment. Internal treatment, removal of hardness causing salt after entry into the boiler is known as internal treatment. So let me see one by one. The residual salt that are not removed by external method can be removed by adding some chemicals directly into the boiler is known as internal method. These chemicals are known as boiler compounds. Yes, the boiler compounds are, it may be inorganic or organic substances. They may are used to remove calcium and magnesium salt in the water sample. This method is known as internal treatment or internal conditioning. Examples: carbonate conditioning, phosphate conditioning, calagen conditioning, and EDTA conditioning. Let me see first sodium aluminate conditioning. Yes, where the sodium aluminate is added into the water sample that may convert it into aluminum hydroxide and sodium hydroxide. And the magnesium chloride react with the excess of sodium hydroxide that may convert it into magnesium hydroxide, so that we can remove hardness producing salt like magnesium chloride into magnesium hydroxide and aluminum hydroxide, which can be easily removed from the water by blow down operation. Number two, phosphate conditioning. It is the phosphate conditioning is used for high pressure boiler. It is superior than that of carbonate conditioning because there is no any risk of CO2 liberation, caustic embrittlement, and boiler corrosion. For better result, we have to maintain the pH value around 9.5 to 10.5. For example, of phosphate conditioning, how it can be treated. Yes, the calcium sulfate can be removed by adding trisodium phosphate. The trisodium phosphate are used to replace calcium ions so that we can get calcium phosphate. The calcium phosphate can be easily removed from the water by blow down operation. Based on the nature of the water, we have to use three different types of phosphate salt. If the water is highly acidic, we must use trisodium phosphate. If the water is slightly acidic, we must use disodium hydrogen phosphate. If the water sample is highly alkaline water, we must use sodium dihydrogen phosphate. Next, I move on to the Callaghan conditioning. It is one of the important conditioning. The question may ask why the Callaghan conditioning is superior than that of phosphate and carbonate conditioning. Callaghan is the trade name of sodium hexametaphosphate. It is represented as Na2Na4PO36. With the calcium ions, it forms a stable complex. So there is no formation of sludge. The sludge material can be removed from blowdown operation. It is used for high and low pressure boiler. For example, calcium sulfate. Calcium sulfate or Hardness producing salt. The Hardness producing salt can be removed by adding Callaghan, like disodium hydrogen phosphate. They may convert it into soluble sludges. And the soluble sludges can be removed from the water by blowdown operation. Next, colloidal conditioning. Colloidal conditioning is used for low pressure boiler only. Here, the scale formation is avoided by adding organic substances like tannin, agar-agar, kerosene, which may get coated over the scale forming substances. This convert the scale into sludges and it can be easily removed from the boiler by blowdown operation. Next, we move on to the topic of external treatment. It is the technique in which the dissolved minerals were completely removed and before entering into the boiler is known as external treatment. Um, Internal treatment is the process of removal of hardness producing salt after entry into the boiler. External treatment is the process in which we can remove all the calcium and magnesium salt before entry into the boiler is known as external treatment. And there are two types of external treatments in our syllabus. Number one, zeolite process. Number two, ion exchange process. Zeolite softening process. Zeolite, otherwise known as permature. Synthetic zeolite are otherwise known as permature. What do you mean by zeolite? Hydrated sodium aluminosilicates is known as zeolite. They are available in nature from the earth crust. These natural zeolites are green color sand. They are non-porous in nature. Zeolites are having the general formula of Na2O, Al2O3, SiO2, YH2. The porous and gel structure of synthetic zeolite is otherwise known as permeatude. These zeolites and permeatude are used for water softening process. Yes, here the sodium salt are loosely held under molecular structure of a zeolite bed so that can easily exchange calcium and magnesium ions which are present in the water sample. Synthetic zeolite is represented as Na2ZA. What is the basic principle involved in the water softening of zeolite process? The sodium ions are loosely held in this zeolite bed so that they can easily replace calcium, magnesium, and copper nickel ions present in the water sample. Yes, in the raw water sample, the water contains calcium and magnesium salt are sent by this way. It is a zeolite bed. The zeolite bed is used to remove only calcium and magnesium ions, which will not use to remove chloride and sulfate ions. I repeat, the zeolite bed are used to remove only calcium and magnesium ions, not chloride and sulfate. What is the basic principle involved in this zeolite process? Here, the sodium ions are loosely held at the molecular structure, so they can easily remove calcium and magnesium salt, which are coming out from this inlet. After reaching the level of up to this level, here the exchange process are happening. Finally, we can get sodium chloride and sodium sulfate water sample. It is otherwise known as soft water sample. After lengthy use, prolonged use, like after 1 or 2 years back, and the column may get exhausted. Exhausted means they are not used to filtered calcium and magnesium ions and that particular situation. So that the calcium and magnesium ions are passed by using concentrated NaCl, which means 10% NaCl solution. The 10% NaCl solutions are washed are used to wash calcium and magnesium ions which are deposited on the zeolite bed. If you use sodium chloride solution, they are used to remove calcium and magnesium ions which are deposited in the exhausted zeolite bed. After treating this solution, we can get fresh bed. What are the reactions taking place during this process? These are some dissolved minerals, which may be calcium sulfate, calcium chloride, magnesium sulfate, or magnesium chloride. Here it is the synthetic zeolite, which is represented by Na2Ze, where the sodium ions are loosely held on their molecular structure so that they can easily exchange calcium ions and magnesium ions. The sodium ions are used to exchange only calcium and magnesium ions, which will not exchange sodium ions, potassium ions, chloride, and sulfate ion. So the zeolite bed are used to remove calcium and magnesium so that we can get sodium sulfate and sodium chloride containing water sample. This water sample is called as soft water. The outcoming water is enriched with a lot of sodium salt, which do not cause any hardness, but it cannot be used for boiler since it may produce caustic embezzlement. Regeneration of zeolite softener on lengthy use after 1 or 2 years back. All the zeolite ions may exhausted. The exhausted zeolite is regenerated by using 10% of NaCl. For example, it is exhausted bed. The exhausted bed is washed by using 10% of NaCl. Here, the sodium ions may replace the calcium ions so that we can get the regenerated bed and residual part. The residual part removed from the boiler by uh, outlet method. Advantages of zeolite process. The outcome of water have least hardness around 1 to 2 ppm only. The zeolite can be regenerated. The method is very cheap compared to that of ion exchange process. Operations are so easy. The space requirement for this setup also minimum. There is no any sludge formation during this process. These are the some advantages of zeolite process. Drawback. What are the disadvantages of zeolite process? Turbidity water. Turbidity water cannot be treated. What is the reason behind this? The turbidity water may block the porosity of the zeolite bed. The zeolite bed can having a lot of pore and voids, and the voids may block in presence of turbidity water. So, a highly turbidity water cannot be treated. And then highly acidic water cannot be treated because the highly acidic water may decomposes the molecular structure of the zeolite. So that highly acidic water cannot be treated. The water containing Fe and Mn cannot be treated because the regeneration is very difficult. The brackish water is it is a water which having some peculiar salty taste is known as brackish water. Mm. I will explain later during the classes of reverse osmosis process. Brackish water is a kind of water having some peculiar salty taste. which cannot be removed by this method because it contains sodium ions. So the ion exchange will not occur. Sodium ions are not exchanged. Next, I move on to the demineralization process or ion exchange process. Here we can remove both anion as well as cations present in the water sample. In the zeolite process, we can remove only calcium and magnesium that cannot be removed by that it cannot be removed chloride and magnesium chloride and sulfate ions. But in this method, we can remove both the calcium and magnesium ion, both the anion and cations present in the water sample. It will say one by one principle. Here, all the cations and anions are completely removed. It uses of two cylinders of cation exchange resins and anion exchange cylinder filled with of two resins. Cations like Ca2 plus, we know that cations are maybe calcium, magnesium, zinc, copper. Anions, it may be chloride, sulfate, carbonate, bicarbonate, bromide, fluoride, etc. What are ion exchange resins? Ion exchange resins are long chain cross-linked polymer. They are resins are long chain insoluble cross-linked organic polymer. There are two types of ion exchange resins are there. Number one, cation exchange resin. Number two, anion exchange resin. Example of the cation exchange resins are denoted as RH2. Example sulfonated polystyrene. Number two, anion exchange resins is denoted as R dash OH twice. Example, urea formaldehyde resin or melamine formaldehyde resins. How we can synthesize the cation and anion exchange resin? The resins are prepared by copolymerization. Polymerization is the process in which a number of monomers are combined to give test. Polymer is known as polymerization. Copolymerization is known as here we are going to use two different monomers. If you are using two monomers, it's called as copolymerization. Here we are going to use two different monomers. Number one styrene, number two vinyl benzene. Both are combined to give test cross-linked polymer. If the if the product is treated with sulfuric acid, which leads to make uh, if the product is treated with the sulfuric acid, it form cation exchange resin. Here the OH plus and the H plus ions are the responsible ion uh, through which we can they can exchange calcium and magnesium ions present in the water sample. I repeat, um, the product is treated with the first step product. The first step product is treated with the sulfuric acid. It forms cation exchange resin. It may be sulfonated polystyrene, where H plus are the responsible ions, responsible functional group. These functional groups are used to exchange calcium and magnesium ions present in the water sample. If the product is treated with the bases and ammonium chloride, it forms anion exchange resins. It is urea formaldehyde resin or melamine formaldehyde resin, where the OH group are responsible for exchanging negative ions like chloride, sulfate, and other negative ions. So, cation exchange resins are used to exchange calcium and magnesium ions, and then anion exchange resins are used to exchange and anions like chloride and sulfate ions. And then working and construction and working of ion exchange process or demyelination process. For this process, we need two cylinder. The cylinder one is filled with the cation exchange resin, and the cylinder two is filled with the anion exchange resins. First, we have to pass the raw water. Sample is sent by this way. Here we can we have a cation exchanger. The cation exchange resins are used to exchange calcium ions and magnesium ions present in the water sample. After removal of calcium and magnesium ions, the cation-free water is sent by this way. Um, Here we are having anion exchange resins. The anion exchange resins are used to exchange negative ions like chlorine and sulfate ions. And then finally we can get demineralized water. Demineralized water means which do not have any calcium and negative ions and positive ions is known as demineralized water. Um, After lengthy use, the column may get exhausted. The exhausted bed is washed by using two different solutions. For example, the cation exchange resins are washed by using dilute HCl, and the anion exchange resins are washed by using dilute NaOH. Working up ion exchange process, the water is paid into cylinder 1, where all the cations are replaced by RH2 resin. RH2 resin means they are cation exchange resin. The cation exchange resins are denoted by using RH2 resin. RH2 are used to exchange calcium ions and magnesium ions present in the water sample. They may convert it into Re, RCA and to HCl. Then the cation free water is sent into the cylinder 2. Yes, the cation-free water is fed into the cylinder 2, where all the anions are completely removed, where R dash OH twice are otherwise known as anion exchange resin. The anion exchange resins are used to remove all the negative ions like chloride and sulfate ions present in the water sample. They may convert it into R dash L2 plus deionized water. So the resultant water is free from all type of ions, so otherwise known as deionized water. Regeneration on long use or lengthy use, all the resins are exhausted, so they have to be regenerated. The cation exchange resins are washed by using dilute HCl, so that we can get a regenerated cation exchange resin. And anion exchange resins are washed by using dilute NaOH, so that we can get fresh beta RHOH twice. Advantages of ion exchange method can be used for high pressure also, since there is no any risk of scale and sludge formation. Then it can treat highly acidic and alkaline water because the ion exchange resins are more stable towards highly acidic and alkaline water. They may resist, but the zeolite that are not used to remove acidic and alkaline water because they may decomposes the molecular structure of zeolite. But in this ion exchange process, we can treat highly acidic as well as alkaline water because the anion exchange resins and cation exchange resins are very stable. They are cross-linked the polymer. They may not decompose when we use acidic water and alkaline water, so we can easily treat it. We can get pure water as hardness as below 2 ppm. These are the some advantages of ion exchange process. Then drawback. What are the drawback of ion exchange method? Highly expensive compared to that of zeolite softener. Water containing Fe and Mn cannot be removed as they form complexes with the resin. Yes, they may convert it into ferric hydroxide and manganese hydroxide, which may affect the regeneration process. Cannot be used for turbidity water as they clog the porosity of the resin. Then periodical replacement of resins are required. Yes, yes, we can we can wash the resin by using two different solutions. For example, cation exchange resins are washed by using dilute HCl, and anion exchange resins are washed by using dilute NaO solutions. What are the differences between zeolite process and ion exchange process? Zeolite process it exchange only cations. Yeah, anion exchange process it exchange cations as well as anion. Yes, and the zeolite are used to remove only cations like calcium and magnesium. They are not used to remove negative ions. Yeah, but the ion exchange process are used to exchange both cations like Ca2 plus Mg2 plus and anions like chloride and sulfate. And the cylinder is filled with the zeolite, sodium aluminum silicate. Here the cylinders are filled with the two different resins. First cylinder is filled with the cation exchange resins, is denoted as RH2, and the second cylinder is filled with the anion exchange resins, which is denoted as R-OH twice, where the cation exchange resins are used to remove cations, and then anion exchange resins are used to remove all the anions, so that we can get deionized water. Here we can use NaCl, 10% NaCl solution for regeneration process. Here we need dilute HCl and NaOH are used for the regeneration. Yes, and the anion exchange resins are washed by using NaOH. The cation exchange resins are washed by using HCl solution. Softening involves removal of only hardness causing ions. Here, demineralization involves removal of all the ions present in the water sample. Yes, and the resultant product having some dissolved minerals like sodium salt, so they may call it as soft water. Here, it involves removal of all the ions like cations and anions. The treated water contains relatively large amount of dissolved salt like sodium salt, which causes caustic embrittlement. Here, that kind of problem is not caused because induced because they may not contain dissolved salt like calcium and magnesium and sodium salt. Because here we can remove all the dissolved minerals. So the treated water does not contain any dissolved salt, so they may not cause any boiler troubles. This setup and operating cost is relatively low. Here, the setup and operating cost is high compared to that of zeolite. The hardness may be up to 10 ppm. Here, the hardness up to only 2 ppm. Acidic water cannot be treated because acidic water may decompose the molecular structure of zeolite. That here in the ion exchange process, we can use highly acidic as well as basic water sample um, because they may resist because the resins are highly stable towards acidic water and basic water. These are the some differences between zeolite process and ion exchange process. What are the differences between soft water and demineralized water? Soft water it does not contain harness producing calcium and magnesium ions, but it may contain other ions like calcium, potassium, sodium, chloride, and ions. So they are called as soft water. It is the product of zeolite process. Demineralized water. Demineralized water does not contain any harness, including harness producing ions like calcium, magnesium, chloride, sulfate, and all. So they are called as demineralized water. Softening involves removal of only harness causing salt like calcium and magnesium salt. Here, demineralization involves removal of all the ions present in the water sample. Next, the last topic is desalination of a water sample or brackish water treatment. Is water containing dissolved salt around 1000 ppm to 35,000 ppm. The peculiar salty taste is known as brackish water. Yes, from the slide we can easily understand. Yes, brackish water is the water that is saltier than fresh water, but not salty as seawater is known as brackish water. Various methods of desalination of water sample by reverse osmosis, a desalination process, electrodialysis process, a freezing method, solar distillation method. These are the several techniques through which we can remove dissolved minerals present in the dissolved minerals like sodium chloride present in the water sample. Desalination of desalination by reverse osmosis. Removal of common salt like sodium chloride is known as desalination. And based on the dissolved salts in the water can be classified into three types. Um, if the dissolved salt less than 1000 ppm, they are called as fresh water. If it is between 1000 ppm to 35,000 ppm, call it as brackish water. If the dissolved mineral is more than 35 ppm is known as seawater. So reverse osmosis is used to convert sea and brackish water into fresh water is known as uh, desalination or desalination, reverse osmosis. Osmosis. When two different concentrated solutions are separated by a semi-permeable membrane, due to osmotic pressure, low concentrated solvent flow to higher one. This known as normal osmosis. This is mainly caused by the osmotic pressure. Reverse osmosis, when we apply an excess and opposite hydrostatic pressure of 15 to 40 kg per centimeter square to overcome the osmotic pressure, then the higher concentrated solvent will flow to the lower one. This known as um, reverse osmosis. So yes, I repeat once again. And the two different concentrated solutions are separated by a semi-permeable membrane. The semi-permeable membrane are used to filter unwanted material which are present in the water sample. Yes. In this condition, the direction of water take place from lower concentration to higher concentration site. This is known as normal osmosis. This is mainly caused by osmotic pressure. Now we are going to apply a high hydrostatic pressure around 5 to 15 to 40 kg per centimeter square in place of osmotic pressure. Now the direction of water take place from high concentration site to low concentration site. This is called as reverse osmosis, which is otherwise known as superfiltration or hyperfiltration. These are some membrane. Examples of membranes are cellulose acetate, cellulose butyrate, polymethyl methacrylate. These are some common examples of membrane. The membranes are used to remove uh, unwanted materials like dissolved minerals, suspended impurities, coloring matter, which are present in the water molecule. Yes, the schematic diagram of desalination process. Uh, when two different solutions are separated by a semi-permeable membrane, and in this condition, the direction of water takes place from low concentration side to high concentration side. This is due to osmotic pressure. Um, Now we are going to apply hydrostatic pressure in place of osmotic pressure. Now the direction of water take place from high concentration side to low concentration side. This is due to reverse osmosis. Advantages of reverse osmosis. The lifetime of membrane is quite very high, which is around 2 to 3 years, which remove ionic as well as non-ionic substances and also colloidal impurities of silica, which cannot be removed by demineralization process. Low capital cost, simple operational procedure. The membrane cannot be replaced within few minutes, and thereby providing uninterrupted water supply. This method is also used to remove biomolecules like sugar, protein, carbohydrate, etc. etc. Drawback, periodical cleaning of membrane is needed. Pre-treatment of bacterial removal is needed. So thank you, students. Thank you so much.